All right. You want to kick us off? Hello. My name is Ben Libell. I'm here to talk to you guys about deploying a web app with AWS. Before we get started, I'm going to just quickly kick over to my Git client because I need to push something. So right now, this is the website we're going to be working with. We're doing Hello World with Hello Kitty. You can use this app to talk to Hello Kitty's friends, and I'll be demonstrating that in a little bit. But right now, I've just kicked off a pipeline with that push to my origin repo, and this page will change by the time I'm done telling you who I am. Hopefully. So my name is Ben Libell. I'm a solution architect here at Slalom. I've got 8 years of software development and engineering experience. My focus for the last year and a half has been very heavily on AWS, but before that, I have a lot of experience in .NET, making web APIs, a little front end here and there, but I'm mostly a back end guy. And right now, like I said, my focus has been very heavily on AWS for the last year, so that's why I wanted to bring this topic to show you guys that it's not as hard as everybody thinks it is to take your code and put it in the cloud. Amazon provides the tools. You provide the code. So all the tools you need to get your website or any other application hosted in the cloud are there for you. You just need to know how to leverage them. Now, if we kick over to my Amazon instance, let's see. We're in the deploy step now. So we'll give that another second. Here's what we're going to talk about tonight. We're going to talk about our app. I'll give you a brief overview of what the source code looks like. It's extremely simple. This was more about the infrastructure than it is about the code. Then we're going to talk about hosting a static website in S3 through what's called a CDN, a content delivery network. All that really means is you've set up your S3 bucket to allow traffic from the internet to come through and access resources in it. We're going to talk about having a basic Lambda function as our backend with API gateway acting as your entry point to that Lambda function. We're then going to talk about routing to your static website with CloudFront. That way you don't have to make your S3 bucket public. And then finally, we're going to go over the automated deployment of this code and this whole application stack beginning to end. And now, what happened here? OK. So let's look at we skipped a slide. There we go. Hello Kitty's World. So Hello Kitty's World is a simple website. We're going to kick over to Visual Studio Code now and look at some of that. And it's literally just a single page that has a bunch of HTML and CSS and some JavaScript at the bottom. That JavaScript is set up to make a call out to an API for Hello Kitty to say hello to one of her friends. And then that API passes back a small JSON object that then tells this application which image to show. So if we kick over to this, and I want to say hi to ChocoCat. Hello, ChocoCat. Hello, Kitty. And we can do that for any of these buttons. These buttons fire off a request that gets done right here. And it goes through to our Lambda function and comes out the other end with that response. We can see that in Postman here, if you wanted to do that without the API itself, or without the front end. You send it a name, it sends back where that image is located in relation to the rest of the website, the height and width of the image, and then the two texts that you want to have come through at the bottom. So now we'll go back to PowerPoint. I'm going to be clicking in and out of here a lot, I think. So all that website that we just saw was coming from S3. You can use S3 to host static websites in Amazon, and that's using it as what's called a CDN, or a content delivery network. You would configure this by putting your index file in the root of the bucket, and then you can configure that bucket on its own if it's publicly accessible to host a static website. That is one of two ways to get to that index HTML file in that bucket. My bucket is not configured that way right now because I changed it over to use CloudFront for routing, which I'm going to show later. But for the sake of example, let's kick back over to Amazon, and I'll show you what it would look like to have that S3 bucket configured that way now. So if I kick over to S3, and we go to this bucket, here's our website. We've got index.html. We've got those 4 images, one for Hello Kitty and one for each of one of her friends. If you wanted to come in and make this a static website, first you would come in here, and we would edit the permissions on the bucket and make it public. Confirm that. And now, these objects aren't going to be publicly accessible by default. You have to set that per file in the S3 bucket. But once you've done that, which I'm not going to show right this second, you come over here to static website hosting, and you would click use this bucket as a static website. You feed it the document that's the root of the website, which in this case would be our index.html. You can do some other settings like redirects and things like that. But literally, all you need to do is feed it the index and hit save at the bottom here, and that will allow you to host your static website. One thing real quick. You come into the Amazon console, and then you type in S3 at the top. And that'll take you to your S3 buckets. And then you click on the bucket that you've already created to host your website or whatever content you've got out in S3. I'm going to kick off another pipeline real quick while we're chatting. OK. And then we're going to go back to PowerPoint. So that is the basic, like, what we're looking at as far as just the static web page on its own. I'm not going to do the slideshow because we're going to have to keep clicking in and out of that. So I'm just going to make this big, and we'll go to the next slide. So our API isn't really a fully fledged API right now. It's API gateway sitting in front of a Lambda function, because this website only has one call that it makes. You could, in theory, set up a bunch of Lambda functions and then route API gateway to each individual function if you wanted to make a simple API the way that I'm going to show you today. But if you're going to make a full like Node API or something like that, there are other ways to host that we can touch on at the end. But let's, for the sake of example, take a look at my basic Lambda function first. So we're going to go to Lambda. We'll look at Hello Kitty friends. So Lambda is basically compute without a server, serverless, right? You feed Amazon a bunch of code here in your Lambda function, a single function to be specific, and it will, up here, have triggers that Amazon knows how to connect to and will route traffic through to your function, do whatever your code says to do, and then we'll return a response out. Right now, I've got this wired up to API Gateway. So API Gateway is a platform in Amazon that allows you to set up API endpoints that can then be routed through to any number of Amazon services. In this specific case, we're looking at Lambda, right? So the way that this is set up is API Gateway is there, and we'll look at that in a moment. you come through and you run through this very basic code that I wrote that parses a JSON body, then checks to see which of the 3 friends you've asked it to talk to, and has a default response of an error message if you didn't give it one of those. So if I went to Postman and typed garbage in, this is the one we would get back. And then sends back a response. One very important thing with working with API Gateway that I learned going through this is that if you're going to call API Gateway from a website on like a browser, it will work in Postman, but won't work from your website unless you set your CORS headers, your allow access control origin, here in your response by hand. We'll click over to API Gateway, and I'll show you now that it says that CORS is set up. But if you don't send that header back there, it won't work anyway. So if we look here, Hello Friends is the API that I set up for this. We've got a post. That's our Postman call that I showed you here. And if we dive into that, you've got your method request, your integration back to the Lambda proxy, right? And this may look complicated, but Amazon will set most of this up for you when you tell it, I want to use API Gateway to talk to this Lambda. And then it comes out the other end and goes out through the front. The URL for this API is this big old piece of garbage here. And that's all configured in API Gateway. So the other request that we can take through is this options request. When you set up an API in API Gateway, you'll be asked if you want to allow CORS on that API Gateway. This is what will get set up for you. And it looks like, and all the documentation in Amazon makes it seem like that this will handle that access control header for you. It doesn't. All it does is it allows that options call to come through. You still have to pass that header back if you want CORS to work properly and not get yelled at by your browser about cross-site scripting attacks. So if we look here, network, and I call another one. Here's our options call. And that's the browser confirming that this isn't a cross-site scripting attack. There's no response on this one. It's just a, hey, am I allowed? And then here's your access control allow headers. And then here's our actual response coming through with our JSON. Again, API Gateway will not work unless you have both of those set up. And it won't work if you don't have that header in your response on the Lambda. And that's our simple API. And then also, for the sake of ease, the way that I set up my code project, which we're going to go through later when I talk about continuous delivery and deployment, my function is right here, just in my source code. You could, if you were to do this as a real project, I would split my website code and my API code and have them in separate repositories so that you could deploy them on their own. But for the sake of the project, and because Amazon starts charging you on your second pipeline, I only wanted to have the one. All right, let's go back to PowerPoint. And actually, I'm going to check on my pipeline really quick. Let's see if that finished. It did. All right. So, hello, Denver Modern Web. Sorry, this took a bit longer than I thought it would. Oh, no. Stop caching Chrome. I didn't ask you to do that. Welcome to Denver Modern Web Meetup. I'll be at about 10 minutes late. So what we just saw was the code pipeline that I have set up with this project. Take my commit, run it all the way through, and deploy everything out to my website. We're going to talk about that in a couple of slides, but I knew it would take a minute or two, so I wanted to kick that off at the beginning before we got to those slides. So we're done talking about our simple API. Let's talk about routing to our content. So I showed you before that you can set up a static website in S3. And that will allow you to have a publicly accessible bucket with a URL that is provided to you by S3. It'll have S3 in the URL, so on and so forth, that lets you have that website available. One, that's not very pretty. Your end user's not going to want to see Amazon and S3 in their URL. It doesn't really look like that website belongs to you, so on and so forth, right? You want to wire it up with your own URL, with your own domain name, all that kind of stuff. So if we come back to Amazon, we're going to look at CloudFront. This is another thing that's simple to set up. So I set up a CloudFront distribution with a delivery method of web. When you do this, it gives you a domain name. You can pay to have your own domain name set here, or if you already own a domain, you can wire that up. I did not do that. I just took one of the default CloudFront domain names that it doles out, just for the sake of example. But this is where you would configure that if you were going to do it. And you can see that I've got the origin wired up to my S3 bucket. So hello world kitty s3amazon.com, right? If we go in here, this is the most important part. We look at the origin that I created. And I'm not going to change anything, but we're going to go into edit so that I can show you the most important part. This restrict access to bucket and this identity are very important. So this identity is what allows I can try. Better? OK. This access identity, Hello Kitty World, Amazon S3, that big ARN there, is what allows the routing to go from the web and that URL that you saw as the host name for this through to that S3 origin URL. If you didn't configure that identity and allow it to go into S3 and reconfigure S3's permissions, you would have to leave your bucket open to the world in order to use this, which in part defeats the purpose of having the CloudFront URL in the first place, because you want to keep that bucket private if you can. If we go over here and look at the permissions and the bucket policy, this block of policy code gets generated when you tell Amazon, I want you to create an identity for this bucket. One thing to note, though, is if we go to bucket access control, you have to have your bucket open to the world to allow CloudFront to write that there in the first place, and then you can lock it down. So I'm going to lock this back down through new public and through save. Confirm. If you lock your bucket completely down and don't amend the permissions too, Code Pipeline won't be able to get to it, which we'll talk about in a little bit. So there's, as with everything that has to do with permissions and networking in Amazon, there are a lot of options, and you have to be very specific about how you dial them in, or things either won't work or will be more open than you want them to be. And again, we can get into that. I'll even show an example of the pipeline not working, because that's too locked down in a minute or two. But to get back to CloudFront, this, and we go, nope, not that, back. This origin is what put that bit of permissions code into that bucket. And at that point, we can lock it back down. And then that means that this URL is able to access that bucket. It effectively, behind the scenes in Amazon, says, I know what this URL is, and I know where this bucket lives, and I know that I'm allowed to talk to it and no one else is, as long as I've locked the bucket back down after I open it up to give permissions. So in an ideal world, when you're building this out yourself, what you would want to do is create an empty bucket with nothing in it, open up its permissions, let CloudFront do what it needs to do to the bucket, and then lock it back down. And so that's routing to your content. And then finally, deploying our app. And we can get into the weeds on this a little bit, because there's some good stuff to talk about here. So there are three things that we're using to deploy our app right now. There's code commit, code build, and code pipeline. We'll start with code commit. Code commit is a very simple code commit. Git hosting in Amazon. You can just put Git repositories out in Amazon like you would in GitLab or Bitbucket or anywhere else. There's a couple of small nuances to the way that you have to upload SSH keys to Git here that are different from other Git providers. For example, if we look at my .ssh folder, I've got a lot of keys in here. I have an SSH config, open with, that is specifically set up to talk to code commit. And you have to have that in order for this to work. Basically, what this says is that my Amazon IAM user is specifically allowed to get to that identity file and talk to code commit. And code commit has, I'll just show you how to start it up a new one real quick. So if we make a new repository, duh. It'll tell you how to get to it via SSH. Like, it'll walk you through it. So I'm on a Mac. Let's look at this. It tells you how to do this. But you have to, one, you have to know that you even need to look here to do it, which I'm going to be honest, took me a little while to figure out when I was like, why can't I connect to this? I have an SSH key. How do I do this? It's not even readily apparent that this is here to walk you through it. And two, you have to understand what we're working with here. So you have to already have an IAM user that you're using to interact with Amazon. And you have to upload your SSH key to that IAM user. So let's go back to IAM. IAM is your access management tool for accessing your Amazon instance. So this Amazon account that I own has an IAM user right now that I'm using to access it. It's my Slalom email. And if we look at my security credentials, access keys. I uploaded an SSH access key right here for code commit. You have to have access to IAM to do this. And a lot of the times when you're working in Amazon, say at your company or whatever, only your DevOps admins are going to have access to IAM to set this up for you. So if you can't do this yourself, you need to contact whoever the owner of your account is to set this up. I've been on a lot of projects where IAM is completely locked out for even power users. And that's just, it's security, right? Not everybody needs to be diving in here and creating users. That's an easy way for your account to get open to the world because someone did something and they didn't know what they were doing. And then you've got someone coming into your account stealing people's credit card information or who knows what else. Or just spinning up EC2 instances in your account and charging your company millions of dollars because they got in. And they're like, sure, I'll have a big beefy machine with 10 terabytes of memory. And that's something that they can do if they can get in here. So a lot of the time this will be locked down. But because this is my personal account, I've got the keys to the kingdom. I came in here, I uploaded my SSH key, and then this ID you see here should, is that just my IAM user? That's probably just my IAM user. But matches with one of the numbers that has to do with IAM, which I'm going to check really quick. That's code pipeline, repositories, test repo. That number is your IAM SSH ID. OK, so then it is that number. Mine must be configured for a different key right now. So that's not necessarily readily apparent when you come in and do this for the first time. I think it's worth talking about because you could spin your wheels for an hour or two trying to figure this out, where it really only takes 5 minutes. You just have to know where to look and what to do. The other thing that you can do with this sort of setup is you could create for instance, a pipeline user that can commit and do things to the repo in automation this way. So you make an IAM user that only has access to, say, your code repository, a pipeline, and a couple of resources that it's supposed to interact with. And that user can do automation for you without ever needing to log in or do anything. And you can configure that all using this method. So that's code commit. Let's look at code build. So build projects. Everything in code build is considered a project. And your projects are basically runners is the way I like to think of it. This is a machine that's going to run some automation for you. It doesn't exist all the time. It kind of exists when the pipeline kicks off, does some stuff, and then goes away afterwards. So if I were to make a new build project, I'm going to show you guys some of the things that you can do here. Project name, that's not super important. So you would pick a source. We're going to pick code commit. We'll pick hello kid. Oh, we'll do test repo. Why not? There's nothing there, but we'll say you can pick a reference type. And this, if I had a master branch, I haven't committed anything to that yet. But you could make master, develop, so on and so forth. And this is basically what is going to trigger this build process once you've got it all set up. Your environment, this is the important part. This is what I wanted to dive in here to show you. So your environment is going to be what type of server. Again, this thing's going to exist for a minute or two and then disappear. But effectively, in old terms, what type of server do you want to do your build process on? So you can pick Amazon Linux, which has its own perks. It's very up to date. It comes with the Amazon SDK already installed on it, full CLI access. You don't have to go crazy setting up permissions and things like that. But if you had simpler needs, you could also just select vanilla Ubuntu. Or if you've got .NET code or other things that require a Windows server to run, you can choose Windows Server. And then it'll allow you to choose different runtimes. Amazon Linux has the most to choose from. So you can pick back versions, say if you have some kind of constraint. If we go to Ubuntu, there's going to be all kinds of stuff here that we can pick from. Let's look at what we got. So standard, yeah, image. So you can do different versions of Amazon code builds, like predefined machines that you can use. And then service role is the IAM role that this machine's going to assume to talk to your resources. So this build machine has to be allowed to talk to specific things. I'm going to cancel out of this, and we're going to go look at my one that talks to Lambda really quick. So source, environment, build spec, artifacts, logs. What are we looking for here? Project configuration. No. Discard. Just got to find where that is. Environment, here we go. So this service role is very important. Basically, if you want to deploy to anything in Amazon, your service role that this build project is going to assume has to have permissions to talk to that thing. So let's have a look at the one that I've got set up here. Oh, that's way too big. Hold on. We're going to zoom out. So I'm not going to dive too deep on what all of this is. But basically, what I've got here is a policy that says this role, and anybody that assumes this role, is allowed to talk to S3, code pipeline, code commit. Let's see. And there's 5 more. Yeah, there's a lot of these. Lambda and ECR, which I didn't end up using. So technically, this role has more permissions than it should. And by all rights, I should strike this last one because I didn't end up using this resource. If we were to get into the nitty-gritty on this, that's technically a security hole. And it's not something that you would want to do if you were setting this up for like a client or your company that you work for, right? You only want to give it permissions for exactly what it's supposed to have. So like I've given it permission to talk to this very specific Lambda function, my Hello Kitty friends. If you tried to run this pipeline without these permissions, though, you wouldn't be able to deploy anything because Amazon wouldn't allow the machine, that Ubuntu or Amazon Linux machine that I just showed you, that gets spun up when you run your pipeline to talk to anything at all. It would be in its own little bubble, doing its own thing, and it wouldn't be able to access any resources. So let's go back to the slides. So that was code build. Oop, wow, good job. The other thing that's important with code build is you have to make a build spec YAML. This is a file that tells your runner what to do. So if we, and this is a simple one. This is pretty straightforward. I'm telling my runner I want it on version 0.2. I want it to be a Node.js 8 runtime environment. And these are the commands I want it to run. So I've got a couple echoes that say, hey, updating the Lambda, creating a Lambda zip. I tell it to zip up index.js. When you deploy to Lambda through the Amazon CLI, which is how I'm doing it, you feed the Lambda function a zip of its function file plus all the packages that go with it. So if this was a node project that had a single node function and you were bringing in, say, I don't know, like a UUID generator from NPM, you would NPM install, and then you would zip up your index.js file plus the node modules that you just NPM installed. And those would all go up together. If you don't do that, you're going to end up with a script out there that doesn't have any of the libraries that go with it. And then to push to S3, we create an artifact. And that's what this little chunk does. What this does is it says, I want to take these files that are in this files list right here, and I want to put an artifact from this build process into an S3 bucket that gets created when we make the pipeline. And that allows this build process to take those files, stick them in that S3 bucket. That's not the one that we're going to deploy them to eventually, but as a temporary location for all of your build artifacts to go. And then that's what's going to get deployed afterwards. This is really important if, say, you're a customer-facing app and you have iterating app versions. So you're about to release version 5. And it goes horribly, horribly wrong. Well, you've got version 4 in that S3 bucket. And you can target that and redeploy it again if version 5 takes everything down. And that's why you want to keep these artifacts over time. It's because if something goes wrong, you always have a chance to roll back. And that's immensely valuable in a customer-facing situation, let's say. All right. So that's code build. Our last one is code pipeline. And code pipeline is kind of the glue that holds all of this together. So if we look at that, I've got one pipeline. And what this pipeline does is it has steps, right? We've got the source step, which pulls my code from the Git repo that I've created on a commit to the master branch. And it says, OK, cool. I'm going to build that code by doing that build step that I just showed you and running those exact commands that you saw in the build spec YAML. And then it's got a deploy step where, because I've given my build process the right permissions, it knows it can deploy to that S3 bucket through that same IAM role I just showed you. So if I were to come into my code and make a change to the Lambda, so let's make Karopi say, oh, hello, modern web. So now, this is a change to the Lambda. We're telling the Lambda we want to change its output for this one thing, right? And then we're going to change the index HTML. Let's just change the title because that's easy to see. Let's say hi. So the reason all my CSS is in line is because I'm not good at CSS, and I was doing this in a hurry. If you were doing this to be a real, proper website, I would recommend building it like you would any other website, where you've got your HTML pages, you've got your CSS. S3 will let you have a full folder structure. I could take the entirety of a full, fully fledged website with its own JS files, its own CSS folder, and as long as everything is routed properly from root, so from the root of your project, you could deploy the entire thing to S3, and all the pathing would be relative to itself.
You might want to just mention, for those that aren't familiar with S3, it's object-oriented storage. You can put anything in there you want.
Yes.
Absolutely anything.
Yep. Folders, files.
SQL databases, whatever you want.
Yep.
Doesn't matter.
It's just an object store. That's all it is. Yep. But to loop all the way back around, the reason all my CSS is in line is because I was in a rush, and I'm terrible at CSS, and I just wanted to make this look pink. And I'm glad to say I succeeded at that. All right, so let's fire off another pipeline. Let's come in here. So we've changed the index HTML. We've also changed our Lambda's code. So let's commit that and push it to master. And let's go back to my pipeline. Now, this should pick up the fact that I just did that. I shouldn't even have to refresh this. I might have to refresh this if my browser decided not to listen anymore. But it should pick up that I did that. It did it. There we go. So it'll see, you can see the latest commit ref right here. So this 40CCA is the same SHA that I just committed right here. And that'll link back and forth between your repo locally and the repo out in Amazon land. And then what it did right now is it's doing my code build steps. Let's look at that. So this whole stuff at the top is the runner getting itself ready. So it's installing Node. It's picking up the Docker version that I wanted it to pull in. And then the white text is what's happening on the machine. The blue text is the commands that I'm running against it. So if we look here, running command AWS -- version, and then it tells me what version of the CLI I'm on. Here is my Lambda getting pushed. So that command there in the blue, running. Can you guys in the back see that, or should I zoom in?
Zoom in.
Sure. Oh, of course it didn't make the text bigger. Oh, it did? A little bit? A little bit more? Ooh, that's hard to read, but we'll do our best. So this command that is now quite long and on 2 lines is the command our single JS file up to Lambda. Technically, you could push an entire Express API to Lambda, all in one. As long as it's pointing at index.js and it knows what to do, technically you could do that. I would recommend against doing that. That would be very expensive for you because Lambda charges for how long that function's running.
Did you just hit the X, right next to the build?
Sure. Yes, thank you. Good call. So again, right tool for the right job. I wouldn't recommend doing that, but the fact of the matter is you can deploy any number of files up to Lambda as well. And if you've got a simple like couple file, like I don't even know what you would use. Maybe like an image processor or something. That would be a good use case for Lambda. But a fully fledged API and a single Lambda function is not what you would want to do. That said, you could do what I did and set up an API gateway with a bunch of individual Lambdas behind it. And that would be a good way to do a serverless API in the cloud. And the reason you would want to do that is because some of your endpoints are going to get more traffic than other. Every API is going to be like that. Your login endpoint is probably going to get hit a lot if you've got users coming into your site and logging in. But maybe the account details endpoint isn't expected to get as many clicks because people are only going to go look at that like once a month when they're coming in to check their billing or something. You would get charged individually based on which one of those are called. So if you expect certain endpoints to not get called as much, Lambda could be a good place to put that specific endpoint because you don't have to pay for it to be running all the time on, like, say, EC2 or something. You could put that individual function behind Lambda knowing that it's going to get a lot less traffic and pay less money for it through Amazon. Let's keep looking at this really quick. So we push Lambda, and then here, this assembling the file list and these lines underneath it, that's our artifact getting made. That's the static website getting packaged up and getting ready to be sent to my S3 bucket. And then, a little too far out, hold on. Our pipeline succeeded. So I did lock the bucket back down a minute ago. Our pipeline was still able to succeed because I only locked it down to new connections coming through because I don't want anything net new going through to it. I want the things that I've already configured to be able to talk to it. If we go back here, and I know your game, Chrome. I have to empty cache. Yay. So let's say hi to Cropy. Hello, Denver Modern Web. Oh, my CSS is bad. It's on the second line. Told you guys, not good at that part. All right, so one other thing I want to show is if we go and lock down that S3 bucket all the way, this guy, right? If we come in here and we go to permissions, and we just say, no, nothing, and we save that, we'll still be able to access this. And this will all still work, which is great. But, by the way, clicking release change on your pipeline will redeploy whatever the most recent commit on your source code is. So what we've done is basically said, that thing that I just ran through, run it again. The build's going to take a minute. This deploy to S3 is going to fail and go red right here. And that's because I've locked that bucket all the way down to all access from the outside. If you weren't doing this sort of pipeline, or you configured your S3 bucket specifically to talk to this step of the pipeline in its permissions, we would be able to get past that. But because I didn't do that, this is going to fail in a minute. We'll click back over to the PowerPoint real quick. And that is pretty much end-to-end how this works. I assume there's all kinds of stuff we want to dive more into. So I'm going to open it to you guys. What do we want to talk about more? Do we have any questions? Is there anything that you wanted me to dive in on? What you got?
When you were first learning AWS, what was the biggest hurdle to get over?
Permissions. I would say permissions.
Question?
Yeah, sure. Yeah. When I was first getting into AWS, what was the biggest hurdle to jump over? And my answer is permissions, not because they're so arcane and complicated that you can't figure it out, but they're so specific and there's so many ways that you can leave yourself vulnerable that you have to be extremely careful about how you set it up. Because it's really easy, like really easy, to go into IAM and make a user that has the keys to the kingdom. You just say, give him admin. And then he's got everything. And you can code for days and wire everything up. But what you've just done is given the world access to your account if those keys go anywhere in the public eye, right? For instance, a perfect example of this is if you've written an API that needs to write to an Amazon resource and you're using the Amazon SDK to talk to it. You have to give it CLI keys in order to do the things that you want to do. A perfect example that I've used in the past is sending emails through simple email service in Amazon. The easiest way to do that in a Node API is with the Amazon SDK. In fact, it's one of the only ways to do it. You have to feed it those CLI keys in order for it to be able to do anything. Because effectively, what that SDK is doing under the hood is just routing calls from your API through to Amazon's API on the other end. You could give it access to the entirety of your account. But that would serve your purpose. But then when you commit those keys to your repo or you store them wherever you store them so that your API can pull in that access key and secret, you've then exposed that access key and secret to the world. And anybody that makes off with that information or like looks at your API calls as they're going through to Amazon or whatever has access to your account. And they can start creating things, destroying things, blowing things up, any number of different things. Yeah. Yeah. Setting up giant EC2 machines to mine Bitcoin in your account. Like, it could happen. And it has happened. So, not in my personal experience, but like, go Google it. I'm sure someone has had that happen to them. The fact of the matter is, the permissions in Amazon are important because it's so powerful. But if you don't spend the time, and I will be the first to admit the documentation around the permissions is terrible. But if you don't go and take the time to learn that, you're going to be in trouble because eventually someone's going to find a backdoor into your applications or your infrastructure. What you got?
Like you were just saying, and I found the same thing, like pretty much all the documentation on like AWS things kind of sucks. Do you have some places that you found better documentation you would suggest?
As sad as it is to say, Google Foo is your friend. I think Amazon's docs are probably the best out there for AWS right now. That's not saying much because I think Amazon's biggest problem with their docs is that they blend the salesy kind of like, look at all the things Amazon can do for you documentation in with the really technical stuff. And that can be problematic because when you're trying to find an answer to a problem, you've got to dig through 10 or 15 pages to find it. And sometimes it's not readily apparent that you're even looking at the right thing.
And some of it feels a bit outdated because like I was trying to set up things and like it was just leaving chunks
Yeah, Amazon tends to run ahead and make things before they're fully documented or even fully vetted out. Rosie and I learned last year that when we decided to use Cognito as our login service, there's a lot of things that it can't do. And there's a lot of things that you would expect a login service to do that stores your users so that I don't have to make a SQL table that has users' hashed passwords with salts on my head. It just doesn't do certain things. Like, there's no rollover process if you want to take one user pool and roll it to the next one. It just doesn't exist. Amazon doesn't have any plans to support it. So if you're going to choose that as your IAM for your site or API or whatever, you have to know that going in. But that's not documented. That's something that, unfortunately, you have to learn through using it. I can't think of any other really concrete examples offhand that I've run into recently. But that's a big one. And that was one that caused a lot of pain for the team that decided to go with that as a platform because of it.
Did you end up switching over something different?
No, we ended up coding around it. We wrote a lot of code that basically, the long and short of it is, we read all the users out of a user pool without their passwords and put them in a database and said, OK, next time someone logs in, if they're not in the new one, we go to the old one, we log them in, we ask them to enter their password again, and then we strike them from the database. It was terrible. Look, it wasn't pretty. It got the job done. None of them knew that we were re-registering them into another user pool. But like, as a user, that's a terrible experience, and you shouldn't have to go through that. Again, and here's our failed pipeline, because I locked that S3 bucket down. I hate to say that it just takes doing, but it really does. It's one of those things where you just have to try things and find out whether or not they work or they don't, or talk to someone who's done it before. Because every week, Amazon is changing something or making something new. 6 months ago, code pipeline looks completely different than it does now. So staying current and making sure you're up to date on what Amazon's releasing is really important. Reaching out to people that are knowledgeable is really important. I would say most of what I've learned is from people that knew more than me. And working together as a group and kind of banging your head against the wall on a problem is also a really good way to do it. Because when, at least today, now when I don't know something, I'll typically get me and another person from Solemn here who's good at this sort of stuff. And if neither of us know how to do it, we just keep trying stuff until it works. Because eventually you'll figure it out. Amazon doesn't make stuff that's broken. They just make stuff that's weird. And you kind of have to piece it together.
It's like a whole journey to Middle-earth.
Kind of, yeah, a little bit. That's a good way to put it. All right, and now that I've laxed the permissions on my bucket just a little bit, it'll let us through. But if you notice, if we come over to my objects, I cannot go to this, even with those more lax permissions. This is just going to fail. All of this is going to fail on us because I've locked down the items in the bucket, which is what we want. This one should fail too, because it shouldn't be cached anymore. Yeah. All of these are locked down. You can't route to any of those directly, which is what you want. You don't want people to be able to get to your bucket from the internet by typing in that bucket URL. We want them to go through CloudFront, because that's where we've said we want our traffic to go. But I know that there's a way for me to make it so that I can lock down that bucket all the way and let Pipeline talk to it. I just haven't gone through and done the policy. Any other questions? Amazon related, anything? I mean, open floor. Let's talk about stuff. Let me do one more. What do you got?
So this is seemingly for a more static website, like you have the files already done. What about more of a server-side rendered application? How would you go about hosting an app like that?
So when you say server-side rendered, do you mean something like an MVC.NET with Razor scripts kind of thing? Or?
Yeah, I was thinking like a job app with JSP files.
Sure. You would probably want to put that on some sort of like cloud server situation, right? I wouldn't use Lambda for that. If you didn't want to do a lot of the more ops-centric work and deal with things like security groups and networking, because you're going to put it on a machine, right? If it's a Java app, you're probably going to put it on a Linux machine out there on. If you were to do it on-prem, it would be on a virtual machine somewhere on a server in a server farm, which is effectively what you're going to do in Amazon. So you would probably set up an EC2 instance and then deploy your code to that EC2 instance. At that point, you would need to set up routing with security groups and probably Route 53 if it's a front-facing website to have traffic go from the internet through Route 53, which is similar to CloudFront, but works a little bit differently because you have to set up the routing tables and the IP addresses yourself. You're effectively taking a domain name and tying it to an IP address in Amazon with Route 53. And then the other thing that you would want to do is if you're going to do it on an EC2 machine, you have to consider, at that point, you have to consider things like VPCs and subnets and the greater Amazon networking, which is, we could get into, but it's a whole other beast all its own.
It's more like it's a virtual data center.
Yeah, exactly, right?
Along with that, we can put even load balancer.
Yeah, you could also set up a load balancer in front of it. And basically, where the world you would find yourself in is, I've probably got 3 or 4 EC2 machines, either in one region or spread across a couple regions, with a load balancer in front of them that lets traffic come through the public and then go to the private where your machines are so that they can do the work and then feed the website back out. Again, that's just kind of off the cuff. There's so much more that we could talk about on that topic. I could do a whole presentation just on that. But that's kind of like the baseline, what you should look at if you're interested in something like that. Sure, what's up?
Do you have any experience with Google Cloud Platform?
Google Cloud Platform? No, I don't have any experience with GCP. I have a GCP account that I've looked at 2 or 3 times, and I have specifically looked at Google's Kubernetes provider because, to be honest, I think it's a lot more robust than Amazon, but I've not like hands-on keyboard done any work in GCP. I've gone to talks and I've listened to things, and I've seen people do stuff, but I have not done any myself. Yeah, that's that. I wish I could talk more about GCP, but I just don't have the experience to want to waste your guys' time with that because I don't know a whole lot. Any other questions? Sure.
Is there any pre-configuration that can happen, or is this all by hand to get your identity set up and everything like that?
Most of this is by hand. A lot of this sort of stuff and how much of this you end up having to do as an individual is going to depend on the team that you're on. Because a lot of times, this sort of Amazon stuff, if you're the web developer on the team and you're working on the JavaScript or the CSS or the HTML for this, or you're writing a React app or something, your concerns are pretty much going to end at, I commit to the repo and a pipeline fires off. And you probably want to know how to watch your build happen in the pipeline, because if your build fails, you want to know why, so on and so forth. Or better yet, if you've got unit tests running in the pipeline, because that's something that would be really good to set up. Like if, for instance, I do my build step here. I could create a build artifact and then have a pipeline step that I put between build and deploy that takes that build artifact, puts it on a machine that functions as if it was going to be the server that it's on, and then run unit or integration tests against it and see if those work. And then if they work, only at that point I would deploy my code. If you're a dev on the team, you want access to all of that. But if you have a DevOps team or an infrastructure team, they're probably going to set up a lot of this for you. If you're a small team and you're working on this all on your own, then you might have to get your hands dirty in Amazon. But the sad truth is, unless you're using Terraform or some kind of infrastructure as code framework, like CloudFormation specifically for Amazon, you're going to be in the console clicking buttons. And none of this is set up for you from the start. You do have to do it all. Oh, and we have a successful pipeline, because I lowered the permissions on the S3 bucket. It's just, Amazon doesn't really do anything for you. There are certain managed services that will set up some stuff for you. Like if you're doing a containerized app, you could set up EC2 machines to be your containers and do all the orchestration yourself. That's a lot of work. There's another service in Amazon called ECS, Elastic Container Service, and that will do a lot of that work for you. You can do either or. And there are things in Amazon that are specific offerings that do a lot of work for you. Cognito is another one. You wouldn't have to set up your SQL databases for signing in. You literally just create a user pool, talk to their API with your user pool ID, and you can sign users up and save their passwords and all of that other IAM stuff. And you don't have to set that up. But again, you are giving up flexibility to work in Amazon's box. There's always trade-offs on that kind of thing. Again, I could do a treatise on just Cognito alone, especially after last year. But as far as like getting infrastructure in Amazon set up for you, you are going to have to go in the console or click buttons or learn to write Terraform, which is how do I want to describe Terraform? A very loose scripting language that lets you tell how to put resources into Amazon. Although, I will admit, and I really like that they did this, in the most recent release of Terraform, they changed it so that you don't have to use their coding HCL language, and you can feed Amazon JSON files now, which is a lot nicer. One, it's easier to read. Two, it's a format almost every developer understands. And three, if you wanted to, you could write code around your Terraform now to suck Terraform files into your code base, edit them or change properties on them, and then feed them back out so that you could create infrastructure dynamically in ways that you couldn't before with Terraform because there was no way to interact with HCL, which was their proprietary writing your infrastructure language. It kind of looked like YAML, but there were equal signs everywhere. It's weird. Any other questions? Sure.
Yeah, have you had any issues with running into any issues yourself with Lambdas and cold starts? And if you have, how did you get around that?
Cold starts, what do you mean?
Like where Lambda hasn't been hit for a while, if you don't have a lot of traffic, it takes a long time for it to spin up.
Oh, I have heard about this. I've not personally encountered it, but I've heard teams that are like doing work adjacent to me or in accounts that I'm in talking about things like this. I don't know personally. I haven't personally experienced it, and I also don't know that there's anything you can do to mitigate it. Because Lambda is so wrapped up in Amazon itself, you're kind of at the mercy of it spinning up the machine, tearing it down, and doing whatever it will. I've even seen, I might have seen when I was setting some of this up, people messaging Amazon about it, and they're like, this is how it is. There might be more to look into on that. I really don't know. I haven't worked with Lambda enough to say for certain whether or not there's a way for you to mitigate that yourself.
Yeah, I mean, we ended up getting around it by setting up a cron job that just hits it every 15 minutes.
Yeah, but that'll end up costing you a lot of money.
Yeah, well, one Lambda every 15 minutes.
I guess that's not a huge deal, but it's still, if you were handling in like the big Amazon account, lots and lots of transactions, that would get costly fast. To put it in perspective for anybody who doesn't know much about Amazon cost models, we recently, on a project I was on, set up a Lambda function to forward Splunk logs out of a Kubernetes cluster to a Splunk instance. And what we found out after we followed like the whole process of getting that set up was that it ended up costing, because of the number of clusters that this project had, the owners of that account a couple $1,000s a month just for that one function to run. Yeah, it gets expensive fast. And it can go way, way higher than that. So it's just one of those things. If you've got something that's really chatty, Lambda probably isn't the thing for that use case. But that's kind of where I'm going to leave that for now. Any other questions, comments, anything else anybody wants to see? Sure.
When you said you use Cognito, why did you choose to use Cognito of all reviews out there?
So I'm going to give a little bit of context there. I did not choose to use Cognito. I was told we were using Cognito, and then I implemented it. At the time, I didn't know of a better tool, and I didn't have the context to make another suggestion, so we just went with it. Looking back, I still think Cognito was the best choice for that team. I just think that team needed to make better decisions about their user experience before choosing Cognito. The reason we ran into the problem we did was because the thing that they wanted to change on that user pool was the password requirements. They wanted really strong password requirements from their security department. They said 14 characters, has to have a number, has to have a special character, has to have a capital. When we launched that application and users started using it, the first complaint that we got from a user experience standpoint was, your password requirements are insane, no one can remember this. At which point we said, OK, we'll dial them back. That was when we found out you can't change that once a user pool is created, and you have to make an entire new one. Yep. And that is why we had to do that workaround. If, one, the team that decided to use Cognito had done the research first and figured out that that was the case, and two, talked to the security department and maybe done a little market research and seen what their users thought of this before we rolled it out to the masses, they could have mitigated that whole situation. But because they went all in on it without fully vetting it out, they got in trouble. Sure.
Out of curiosity, though, what were their password requirements before and what did they dial back to?
So their password requirements initially were 14 characters, must have.
Prior to Cognito.
Oh,
So what problem were they solving?
they didn't have a web portal before Cognito. This was their first foray into, this was their first foray into a web payment portal for their customers. Yeah, and so prior to this, it was all done in retail locations with consultants. And so,
Oh, so this was journal public facing?
yeah,
And they wanted to go with 14 character passwords?
yes. And that's why it was immediately dialed back. But what they didn't consider was the ramifications of using Cognito with that requirement of being able to change
Well,
things.
the way that you're describing it, too, it sounds like they're not really in a position either to implement password aging.
No, they weren't.
Just set a password that's there forever, which, of course, is a horribly bad practice.
Yes. Well, Cognito, fortunately for them, has a default that says you must change your password at this point. But you can't change the requirements on a user pool without building a new one.
It's always going to be 14 characters, always have to have uppercase, always has to have
Always in that user pool, yes. You would have to create an entirely new user pool and lock that setting in from the start. Yeah.
Yeah, they don't mention that.
No, they don't. They don't publicize it at all.
Would you, do you have any that you suggest? Like, I'm doing a mobile app.
Password requirements or?
An off.
Oh,
Online off instead of your own backend server. You would suggest that works.
I have heard very good things about Okta. I've not personally used it. Okta, yeah. The problem is Okta is expensive. It's not free, and as I understand it, the reason that team didn't go with Okta after our debacle with Cognito and they went with Cognito again was because Okta was so expensive.
And the other side is called Auth Zero.
Auth0 works, yeah. I've heard of that one too. I don't know anything about that one though.
There's also Ping. I don't have experience with it, but I've seen it's usually Ping or Okta a lot of the time.
Ping, you said?
Yeah.
Ping is another one that you might be able to use. Yeah.
Yeah.
Well, yeah, of course, if they're a good solution, they're going to want to.
Yeah, of course. I mean,
After is everywhere now.
yeah. The name of the game with a lot of these things is you get what you pay for. Yep. And if you try and cheap out on things, you're going to end up either having to jump through hoops or have a half-baked solution. And it stinks, but that's just the reality of the industry we live in. I've got time for one more. What you got in the back?
Are there any things that AWS is not particularly well suited for? Like, are there any holes in what they haven't brought out yet? And if so, what might those be?
I think, in my personal experience right now, and I by no means have touched everything that Amazon has to offer. Not by a long shot. That would take years. But in the things that I've worked in up to now, I think someplace that falls a little bit short is Kubernetes. And that's because while EKS, Elastic Kubernetes Service, exists, if you look at what it's doing under the hood, all it's doing is spinning up EC2 instances and doing some of the Kubernetes wiring for you. And at the same time, you end up having to do a lot of work on your own anyway, even if you're using that. Yes, it's managed, but it's not managed the way that Elastic Container Service is. I don't know that the GCP offering for Kubernetes is better personally because I haven't used it. But I've talked to people who have, and I've heard that specifically if you're going to be doing Kubernetes, if you're not a networking wizard and know how to wire up your nodes and your master and all of the bits that surround Kubernetes, you may be better off using GCP. Thanks for coming, guys. I really appreciate your time.
If you have any friends you think should give a lightning talk, reach out to us.
Thanks for coming, everybody. If you have any extra questions,